Welcome to Embedded. I'm Alicia White, here with Christopher White. Our guest this week is Jonathan Beri. We're going to talk about Silicon Valley tech careers and after-work engineering.
Hi, Jonathan. Welcome to the show.
Hi, Chris. Hi, Alicia.
Could you tell us about yourself?
Sure. So my name is Jonathan Beri, as you mentioned. I am a product manager at Particle, a full-stack IoT platform. I'm a former Googler and gelato enthusiast.
All right. Well, I know you've heard the show, so you are familiar with Lightning Round, where we ask you short questions and want short answers. And Christopher, why don't you go ahead and start?
Favorite gelato?
Banana.
Really?
Banana.
Not expected.
No, that was really not what I expected. Tip you think everyone should know?
Let's see. Always check polarity.
That's the voice of experience.
Do you prefer to complete one project or start a dozen?
Dozens.
Multiple dozens. Hacker, maker, tinker, engineer, or programmer?
I would say, well, earlier in my career, I used to claim I was a computer scientist. And now I think I'm comfortable with maker.
Favorite programming language?
Today, C++. Otherwise, JavaScript.
Arduino Uno, BeagleBone Black, Raspberry Pi, or something else?
Lightning round question, huh? All of the above. It really depends on who you are, where you are in your career, and the application.
For yourself, for today, whatever you're doing today.
I have an Uno handy pretty much all the time.
Okay.
Favorite motor?
There's a very, very tiny stepper motor. I think it's a NEMA 17. No, NEMA something or other. But it's so cute. It fits in between your two fingers, and it's a stepper motor.
That sounds like fun. Little tiny thing. Okay, so enough with the lightning round, unless you want to answer your this question that way, which is, could you walk us through your career? I think would be harder than the lightning round question.
Maybe not lightning round, but I'll try to keep it short. So let's see. Career-wise, I started. Let me go back to college and kind of how I got to where I am today. In high school, I was very much one of those science people, and somewhere along the line, I decided I wanted to build robots. And in order to build robots, I figured out that you need to know mechanical engineering, electrical engineering, and computer science. And fortunately, I knew a little bit about computers, a little bit about electronics, and knew nothing about mechanical. So I said, okay, great. I'm going to go study mechanical engineering, an undergrad, take graduate courses, and become, an electrical engineer expert and a computer science expert, and I'll be a roboticist. Check, win, right? But as many of your listeners and people who go through college experience, I had a different path in front of me. So I started it as a mechanical engineer, which was so much fun, and especially the hands-on parts, learning CAD and building prototypes. But the the math part was not as fun, especially applied math in mechanical engineering. There was I remember there was a very important class that made me decide not to pursue mechanical engineering. It was the statics class, where it was just a whole quarter of beams.
Yes.
A beam on the wall, a beam on the floor. How much will it deflect? How much will it, if you drop something on it, which way will it go? And it just didn't resonate with me. And I decided that I didn't want to do mechanical engineering anymore. And looking at my previous coursework, I said, computer science, I really had a lot of fun doing it. I even liked electrical ones. So I switched to computer science. Let's see.
But not only computer science.
That's right. So I switched majors and I had some classes to backfill, but I didn't know what I wanted to do with computers. I really didn't understand the industry. I had no one to really talk to about it. So I decided to do a bunch of different internships. And this was probably lucky for me that I made this decision early on and just try completely different disciplines. So I did IT at a major hospital. What else did I do? I did AI, doing image processing for a crazy physicist manager, which was really fun. Web and database stuff, and they all had fun parts to them, and I excelled in all of them. But it wasn't quite right for me. I didn't know why, and I got great advice from the chair of the CS department. He said, "Well, you're not the typical software engineer. You don't want to be in the basement of the computer lab and code there until 5 a.m. Have you thought of product management?" And I had no idea what he was talking about. And at the time, you couldn't even Google the term product management and find anything useful. But I did some research and I met with some people in industry and decided I wanted to do product management. It seems like a good fit for me. So I wanted to learn more of the business side of of building products, and found out that there was a brand new major at my university, which was a double major. So computer science and business administration. Certainly a guinea pig program. I was one of 4 graduates with that degree, but it definitely helped me get into the product management.
Okay, so product management to me are the people who interface between either customers or marketing, depending on the size of the company, and the engineers. They're the ones who say, no, what we really need is for that button to do X, or for the screen to be a little bigger or a little brighter. But also, sometimes the product managers can help with the entire state machine. It's like, when you do this, when the user does this, that should happen. But they do a lot more. Or how would you really describe that role?
Yeah, not quite people persons, right? There's this sort of romantic narrative that product managers like to say that they're the CEO of the product, which means nothing, and it doesn't help anyone understand what you do. And to be fair, the industry doesn't have a good definition, because someone might be doing product management as a engineering manager at a company, or they might be an intern who does a little bit of product management. And it's really about the functional role I like to think about. And if you look at a small company, let's say it's 2 co-founder company, right? What are they going to do, right? They have an idea of a thing they want to build, a problem they want to solve in the world. So somebody's coming up with the product. And then somebody's coming up with the design of it, if it has a user interface or user experiences. Then there's a technical person who's designing the solution and implementing the product and building it. Eventually, somebody is going to have to sell it. Somebody's going to have to support it. And that is the bulk of typical companies, right? You have your executive team, your leadership team, you have your engineering team, your sales team, your customer support team, and maybe designers. And you'll see a lot of companies structured that way. But eventually, you're going to have to decide what to build and what not to build. And one way to do that is to understand the customer, understand their pain points, understand the industry and competitors, understand your limitations as a company and where you should invest in or grow. And all that spits out and comes up with what the product definition should be. And the day-to-day of a product manager is writing product requirements. So saying, here's the things that we should do based off of all of my experience, all of my research, talking to engineering, talking to product management, other product managers rather, and this is it. This is the from the mountaintop kind of thing. What ends up happening though is some companies might have a person with a title program manager that's actually doing product management, or vice versa, or like I said, engineering or the CEO might be doing some of that definition. But at the end of the day, it's what should we be building? What should we not be building?
And it is, to me, sometimes a translation position, because marketing looks at people in specific and in general, and engineering looks at the technology, and you need to find the overlap in order to create a product.
Oh yeah, totally. Especially in the types of products I work on, which are developer products, which are deeply technical. The marketing team can really go out and tell a story, but they may not be in the position to understand how the technology works, especially if the technology benefits the customer in some way. So the engineering team is laser focused in on building, and sometimes engineers don't speak marketing speak. So as a product manager, part of my responsibility is to tell that story and be that bridge, certainly.
And it's good if it goes both ways. So many times the marketing requirements involve breaking the laws of physics. And so the program manager role, when the person who's filling it is from marketing, sometimes doesn't see the importance of understanding the technical pieces. You come from a pretty technical background. Do you have trouble with the marketing people thinking you're too much of an engineer?
The truth is, all product managers have the largest imposter syndrome, and we pretend to be marketing, we pretend to be engineering, we pretend to be sales. So you wear a lot of hats, and I have no marketing background except for the little bit in school I picked up, but I have to understand the sort of the science and, black art of marketing in order to talk to marketing effectively. And then I need to be able to understand, speak like an engineer, but not to come off, naive, and bridge the two. Constant challenge.
And you talked about program management. To me, that's the person who kind of monitors the schedules and plans ahead and deals with resources. Is that what you mean by it too?
Yeah, I think that's generally true. Certainly, I worked with folks who their title are program managers, but they have a CS degree, and they fill the void oftentimes where a product manager or there is not around, or there is no product manager, and they have gotten close enough to the engineering team, know enough about the customer to fill out some of those requirements. But generally, a project and a program manager manages projects individually as a sort of a standalone project or a larger program, and that's what a program manager would be.
Could we get fewer things that are abbreviated PM?
Yeah, maybe. That's a little confusing.
It's also product marketing, right? So,
yeah, there's I've seen it as PDM, PGM, PJM, PMM to try to disambiguate, and that doesn't help anyone.
And for a small company, it is very likely there is one person filling all of those roles.
Yeah, totally. In many companies, they don't have product managers or program managers, and the CEO and the engineering or the technical co-founder is that function.
Okay, but you didn't stop doing hardware and software on the side, even though you decided that wasn't your career path.
Right. So I was kind of guided on that path anyway, working on developer products. So if we're building an SDK, I should have used the SDK in order to understand the pain points of our customers. So I was always coding even after college, but just not real code, right? Just samples. And at some point, I was in a conversation, and I can't even remember the exact conversation, with some fellow computer science majors about embedded electronics, Arduinos. And I happened to know one kernel more than the rest of the group. And I was able to answer one question about, LEDs or something to that effect, which made me feel inspired. And I decided to pick up a Spark Fun Inventors Kit, do all the examples, and that really kickstarted my career deviation, if you will, to be more around the embedded system and hardware side of the world.
Was this while you were at Google or before that?
This was at Google, yeah.
Okay, and you were at Google for about 6 years, and you left a few months ago.
Oh, yep, that's right.
So did they approve of your extracurricular activity? Was this your 20% project, or was this entirely on your own and they never really knew?
Well, a little bit of both. Google in general has always been encouraging for folks, whether they're in engineering or not, to explore outside hobbies, contribute to projects that may help Google and its brand, but also just for fun and interest, including open source or community projects. I had a couple hardware-related 20% projects, which were really fun to be part of, but that was well after I started playing around on my own. I would say, in general, one of the skills that helps keep a product manager sharp is extracurricular exploration. So reading every RSS feed you can around your industry and your competitors, or playing with your competitors' products or hardware, trying out new things so you can be sharp on whatever area you're working on. And so that felt natural to me. And I wasn't working on hardware. That just happened kind of by chance. But I started just doing a lot of extra learning and experimentation on my own.
I think it's important even for engineers to look around their industry. I remember after I left Leapfrog and then the Apple iPad came out, when I went to go have lunch with friends there, they hadn't ever touched one. I'm like, no, you have to understand this is a new thing. You really need to see it because it will affect how we teach kids to read. And that's what you're doing. So you can't just put your head in the sand and hope that your product's the best.
Yeah, people at companies in particular who don't use their own products, and I'm not even talking about dog fooding your own product, but just be an actual user. It's really hard to empathize with your customer. And it's also hard to innovate because the moment you stop finding all the pain points of your product, somebody else will have found it and built a better thing.
Well, the flip side of that is companies that prohibit employees from using competitors' products, like Microsoft for a while. You can't have an iPhone, that kind of thing, which I think is equally distressing because then you tell yourself all sorts of stories about how great you are and then you don't have any idea what the other stuff is.
Yeah. Okay, so you were at Google, you had some extracurriculars and you were learning stuff and it fed into your job. Did it just click over after 6 months you had been working with your SparkFun Inventors Kit and now you were an expert and poof, now your day job is embedded systems?
Definitely not. It was a multi-year journey. But there was an actual interesting inflection point. There was an open source project that was just coming online for targeting software developers to play with hardware. And it was using Node.js, which was very new at the time. And it was having crazy ideas of, talking to GPIO and Arduinos. It was called Johnny 5. You may have had it mentioned on your podcast.
I think I remember that, yeah.
And it was just a very simple idea that JavaScript is event-driven, GPIO is event-driven. Let's use JavaScript to control GPIO. And Rick Waldron, who created the framework originally, was at a JSConf. And I watched this video and I said, I get that. I understand what he's saying. I understand how to code in that. I can build a little robot. And on stage, he had a little robot that was driving around and had a sonar sensor and it avoided, obstruction. But there was one thing that really bothered me about his demo, and that was it was wired. He had a really long USB cable hooked up to his laptop while the rover was moving around the stage. So I said, hey, here's a challenge. I can make that wireless. He had a Raspberry Pi on board, so why not just put a wireless transceiver on it and a little battery pack and make it go? Wait, it didn't actually have a Raspberry Pi on board. It just had an Arduino Uno on board. So I said, let me take a Raspberry Pi, which was the first version, wireless card and a battery pack. So I did that, and I published my source code, and I tweeted at Rick saying, "Hey, I think I made the first wireless Johnny 5." So that helped me become part of the community, helping people port projects to Raspberry Pi, and was helping Rick and the other contributors to making work on Raspberry Pi. Writing device drivers for motor controllers, and just generally being the Raspberry Pi guy for a while.
But you had a full-time job at Google, which is not known for being full-time, 30 hours a week sort of full-time.
Yeah, that's right. But it was interesting because it helped scratch an itch. And I think at that time I was doing a little bit of the same thing, and it was getting a little bit slow in my day job. So my brain had this extra opportunity of processing and being creative. And so it was a good balance, especially where I was.
I find that after work stuff for me is usually the opposite of whatever I'm actually working on. So if I'm doing something that involves a lot of management and a lot of people work, then I'm happy to code after work. But if I'm coding all day long, that's not what I want to do when I get home.
Yeah, I guess I don't code all day long, and I haven't done it for a while. So usually when I'm home, I'm doing coding. And that's a good observation. I think it's the same.
Well, would you want to come home and do the product management and people interfacing?
How do you do that as a hobby? You yell at your pets? I already do that. I guess that's what I do.
No, I mean, open source products still need people to help limit the scope. I mean, we can build anything we want to. What are we going to ship next week? Even as an open source product, you still have to ship things.
And I would say, knowing quite a few open source maintainers, the hardest part of running a big project, or even a small one that has a lot of passionate users, is the non-coding part, right? The figuring out what to build next, the roadmap planning, the marketing side of it, trying to get the word out there. But no, I don't come home and do that.
And so this difference between what you do during the day and what you do at night, is that how you avoid burnout?
I've definitely been burnout in my career in the past, and it had nothing to do with the balance between work stuff and not work stuff. It was really burnout at the job. And the way I manage burnout has been recognizing it and switching out something, whether it's the field I'm in or the vertical, maybe it's the team or the location. But the sort of the daytime and nighttime has been more about what I'm doing today is, while it's interesting and it's stimulating, it's not scratching one itch, whether it's deeply technical or fun and interactive or, interfacing with lots of humans. So that doesn't help me with burnout per se, but definitely helps me round out my overall, happiness.
Cool. How do you identify burnout?
In the times that I've been burnout, it's been through external, friends and colleagues. A manager who noticed that I'm not the same and called me out on it. That was probably the first time I had career burnout. And then just, friends and family saying, you're coming home every day. You don't want to talk about work. You're not happy. You don't light up when you talk about what you're working on. Something's different. And I think I've gotten better at it over time. So I haven't been burnt out in a while. And recognizing it before it happens, as my, the way I feel about my job changes, try to course correct before it happens.
It's hard. I think a lot of us experience burnout, and I don't notice I'm doing it. And when I tend to start the cycle, it's very much a spiral for me where I will do more and more code and stare at the screen for longer and longer and somehow work so much harder, which makes the burnout go faster. What I need to do is walk away and get perspective and not just stare and hope it gets better. Taking the steps is required, but not usually what my mental frame tells me I should do until long after I should have done it.
Yeah, and I found that in those times of starting to get burned out, I'll even take on more responsibility or more complexity versus the opposite of what you just described. Yeah.
Sometimes I need a simplification, and sometimes I need something more interesting to work on. And I'm working on something that's boring, and so I'm going to do it the best as I ever can, even though that is pointless at some level.
Yeah, I think there's a lot of confusion sometimes about whether it's burnout because you've really worked yourself to ashes versus being bored. There's different kinds of things. And I've experienced both, and you feel really tired when you're bored at a job, but then you go on to you quit that job and go on to a much more challenging job, and immediately things pick up. So it's not that I was really tired. It was not that my brain was used up. It was that I was bored. But there's definitely been the other way too, where it's like, I can't think anymore.
And then you go to a new job and you still can't think anymore. And that requires time. That's a strained muscle sort of problem.
Oh, exactly.
Okay, you mentioned robotics and saying, okay, that robot shouldn't have a wire, which I think is true of all robots. And you were one of the contributors to the JavaScript Robotics book from Make. Well, what did you write about for them?
Yeah, so that whole experience of making the first wireless Johnny 5 robot and documenting it and helping the community was basically, I was offered and asked to contribute my chapter about that experience and a little bit about the history there, but more about building a mobile robot. So I documented the experience of doing it in the beginning, but really a more modern and cleaned up way of building that robot. And for me, it was my first time authoring anything that was published and doing high quality pictures and trying to being very pejorative and, reduce complexity for the reader was a lot of fun and a lot of work.
A little bit, yeah. What were the hard parts about it?
I would say it's very easy to write a lot of words. And, this is
go NaNoWriMo.
Right? To be Chaucer and get paid by the word would be fantastic. But I think it's really hard, and I'm very humbled and respect people who can write fewer words that are more instructive. So starting with this really long draft, no pictures, and had to get it down to a certain page count. But the instructions, for example, in the book, the chapter, you use a Raspberry Pi and you use Node.js, and it's running on the Raspberry Pi. Well, when I built the first robot, Node.js wasn't officially ported to the ARM architecture. So I had to do cross-compilation and deal with whole sorts of craziness to get that to work. And when I started the chapter, there was a unofficial port of ARM and Node.js. So the instructions were, here, go download from this sketchy website and make sure it works and everything's okay. But towards the end of before the publishing date, there was an official port, and I had to scramble and rewrite that. And that changed the steps you do and the troubleshooting area, and just that whole process of writing really clear and concise and infallible instructions was just so hard.
And having it depend on open source things that change, that's scary too, because you don't want it to be out of date right away, but open source things like Johnny 5 can be a little House of Cards-ish. Mm-hmm. Did you run into more problems in that area?
So when the book was published, it was all good. It was all nice and stable. Johnny 5 was okay. Node was okay. It was a year later, or a year or two later, where somebody on Twitter reached out to me saying, "Hey, all this has changed," and it wasn't because there was the swell of changes in the open source community and breaking things and making it chaotic. It was that Johnny 5 released a motor library that was well designed and worked, and that wasn't available when I wrote the book. So they just asked me, "Hey, here's all this code that you put, and I think I can just use this one line instead. Could you help me make it, figure it out?" So I spent some time, and it just simplified the example code. So there's somewhere a addendum to the book about, half the code kind of thing.
And so you have to maintain your own open source code.
Open source code that lives in a book forever.
Yes. That can get tough. Because it can be, it seems like, oh, I'm going to write this chapter in a book. It's going to take me a while, but then it's going to be done. But it's never really done, is it?
No. And I would say what's interesting, one thing I learned from that experience is when you work on open source projects, which I do for work, and you contribute to the whole stack, whether it's all your own code or you're using other people's projects that you feed back to, it makes documenting things a little bit easier, right? Because at least you control part of your own destiny. But if you're building something or just writing a book, for example, on code written by everyone else but you have no control over its fate. And that becomes a lot more of an interesting challenge to maintain and deal with.
Do you have any advice for people looking to get into open source?
Yeah. There's actually, in the last year or two, been some really good resources published online from how to design an open source project, from the engineering aspect to how to maintain, how to deal with bad actors and creating a community to welcome people. GitHub released a bunch of content. Google released a bunch of content, and there's all these great tools now for automating pull requests and stale issues, etc. So it's actually a really good time to be in open source.
Okay, we'll get some of those links from you so that I have them for the show notes.
Yeah, definitely.
It's funny. I like open source. I'm willing to write code that is open source, but I don't necessarily want to play in some of the open source groups that aren't known for being nice. And since I don't really know any of them that are known for being nice, I just kind of do my own thing and don't worry about everybody else. How do you find a community that's open and accepting and is a community for yourself?
Yeah, it's a great question. When I started my career, I was in open source, and the company I was at contributed to open source. And I had no idea that there were toxic cultures in open source. And I was just completely oblivious to it, partially because who I am and which area I was in. But there are horrible, black corners of open source. But like I said, this is a great time to be in open source because there are now communities who just don't allow that, whether it's organic or big companies behind it because of press reasons. And you're starting to see codes of conduct and lead maintainers shutting down negative comments and blacklisting people who are just toxic to the community. So there are certain signals you can look when you decide to use a project and then also contribute back, how they manage their community and their forums, and things like code of conduct, etc.
I guess looking for a code of conduct is a really good start because it's fairly rare still, sadly.
Yes, totally.
The Linux kernel must have that.
Back to robotics. Robotics is such a way to get people addicted to playing with the hardware, because seeing things move is magical. But it's tough to get it from the position of it did what I wanted once in a sort of janky, shaky motion to it consistently does what I want. Do you know what I'm talking about with that?
Yeah, it's the uncanny valley of technology, and not uncanny as in robotics uncanny, but there's this huge gap from proof of concept to prototype to real thing, and actually that I find a lot of times the proof of concept phase is actually really hard to get to, because just because you got an LED to blink or motor to turn, it's not actually proving out your core idea. In the software world of mobile apps and servers, I feel like the industry has helped bridge that gap where you can say, well, I built my web app in a hackathon. Great. Now I can go out build a product. Where in the hardware, embedded, robotics, IoT, all these different spaces, we don't have good tools to get us from blink of the lights to proof of concept yet.
They're getting better. I mean, we went to our local electronics store and they had a whole wall of new small dev kits for cheap, and they had all the different sensors and a decent plan for putting together something fairly large. I was impressed. And I mean, SparkFun. I remember when SparkFun started and you could buy jumper wires and it was sort of magical not to have to solder everything together. It is getting better, but robotics especially is one of those spots where it's still really hard because the power requirements, I'm not a power engineer. I'm not even a hardware engineer. I just want to type on my little keyboard and I want it to move. Are we going to get someplace that's easier to get to proof of concept soon, do you think?
Yeah, and you hit on a good point around dev kits and breakout boards. The sort of world of complex projects, I think of robotics and IoT kind of as these really complex problem spaces are actually complex because they're systems of systems, right? So
yeah.
Your sensor is not just a sensor; it's a fusion algorithm and a serial protocol, and then there's an aggregator, and then that's before the brains of the operation actually do anything useful. And with dev kits, right? These sensor modules, they simplify some part of it, and the accompanying library that is now produced and available through whether Arduino IDE or Adafruit is simplifying parts of the subsystems so that you can construct these more complex systems more easily. And I see that path. When it comes to specifically robotics, there's a huge opportunity there. I don't know if you've played with ROS and like me hit your head against the wall.
So much. It was so cool. It was so fascinating. And I managed to read like 2 whole books in order to get it working and functional. And then I couldn't figure out how to simulate my robotic arm because I just don't have enough mechanical knowledge to know how to do linkages.
And this is where I like hang my head and my shoulders down. I'm like, we have so many other tools and so many other areas to build far more complex systems than your basic robotic simulation. But nobody's built it for robots yet. I've seen a visual designer who can mock up a mobile app, a fully functional mobile app, all graphical, with high performance UI, and it actually spits out the full app when it's done. And the same thing in sort of simulating a quadruped that just needs to kind of limp around is just so hard and so complex. And I actually had a fun lunch. I got invited to the X lab, to now Alphabet X, to talk with some of the roboticists there. And they have a background in academia and they all use ROS in university. And they told me the story behind ROS, how it started out in academics and all these academics knew nothing about developer tools and user experience. And they just needed a thing that could communicate from a very expensive sensor to a very expensive computer. So they just made a thing and it just kind of worked. And then over time, people started contributing things that kind of worked. And nobody liked it, but it just all kind of worked. And they got through their dissertation and their graduate work kind of limping along. And it's been good enough up until now. But when you build these really complex systems with people who don't have 6-10 years of education, good, kind of works is not how it makes it easy to build that proof of concept. You really need to simplify the individual components down.
Exactly. And I mean, this goes back to open source and how fast it changes and how it can be chaotic. And Robot Operating System had a lot of that with it, where there was, if you were on the wrong version and you wanted a library from a different version, you considered the PhD would allow you to do that, or you just kind of waved goodbye to that little feature and hoped someday it would come about. Very House of Cards-ish.
I'm torn because on one level, yeah, I think there should be better tools and things should be easier. But on the other, I do worry about the commoditization of hard things. I mean, some things are hard because they're hard. And if you don't understand the background behind them, then whatever you're building, you don't truly understand. Do you know where I'm going with this?
Oh, absolutely. And I mean, I fell apart when I had to get to the linkages because I didn't truly understand how my robotic arm worked.
Right. But if somebody fixed that for you with a tool to just spit out the linkages, you would have moved on to the next step, right?
Yes.
I don't.
But I learned a lot doing it. You don't have to learn everything from first principles.
Right.
Yeah. And I think there's this a very important role for those who are deeply, know a domain really well for the next generation, sort of pushing the envelope. I'm starting to learn a little bit about machine learning and trying to wrap my head around TensorFlow and the other libraries out there. And I will never invent a new, algorithm or come up with, quantum computing and machine learning. And I don't have the capacity, don't have the education, or even the desire. But I can start using machine learning in our future products because I understand it enough and I can make it do a thing. So I can talk to the people who know are the PhDs and can invent the new thing. But for this there's a large opportunity basically for people who don't understand how the thing works, but still make it useful. Maybe machine learning is scary to let people just build things without understanding, but in other domains that might be very
like
applicable.
CRISPR and genetics.
Yeah, let's just try it. It'll be fine. If we don't get it right this time, we'll get it right next time. I have been doing some machine learning as well, and it is frustrating because I want to understand every piece, but I also want to not spend 5 years understanding every piece. It's very much I wish I could matrix style jack in and get all the information just downloaded so that when I run into a problem where the back propagation is leaky and that's the cause of all of my errors, I don't look around and go, I don't remember what back propagation is. You? It is hard. There's this war between making things simple enough to use and hiding the complexity that makes them what they truly are.
Yeah, and I think you hit on a point earlier. We just need the spark fund for robots or the spark fund for machine learning. Give a simplification down enough where it's still powerful for those who invest a little bit, but not so much so that the learning curve is too high to get started.
Oh, well, then skip TensorFlow and go straight to Keras. That was so nice. It was very Spark Funish. I mean, here's a module, here's how you use it, here's how you don't use it, and don't worry about all the TensorFlow pieces. I liked Keras.
Cool. I'll check it out.
Not everybody did, but okay. So, so we're talking about robotics in general, but you have a specific robotics task you have been working on recently involving boards, like PCB boards. Could you tell us about it?
Yeah. So one of my dozens of projects I've started and not finished is actually in the space of making things at home and quickly. And there was this great debate on one of the sort of somewhat toxic Hackaday articles a couple of years ago about cheap PCBs, nobody needs to make their own PCB. And then the graybeards are, it's really easy to etch your own PCB. I've been doing it since the 70s. What do you young kids know about anything? And I thought about it, and I had no opinion because I wasn't making PCBs back then. But there was something about the immediacy of having a design. And coming from more of the traditional server and mobile world, you write some code, you hit run, and you get a response. It's it changes the way you build things because you can iterate and perfect your design a lot more rapidly. So I said, well, what's the rapid iteration for electronics? And I did some math in my head saying, okay, well, if you took the entire process of building a board, designing a piece of electronics, and you reduced everything you can down to zero, that's all the software. So you download a Gerber file, you download some code off the internet, you have a mechanical CAD part. The thing you can't reduce down is the manufacturing of the board. Even the assembly of the board you can do by hand pretty quickly. So I said, well, how would you go about making a desktop tool that helps you make PCBs? And I thought about etching, and I learned how to etch when I was a kid. My dad taught me in his garage, and it was messy and it was toxic, and it's actually not very precise. And those who can do it really well have spent years perfecting it. And so I said, hey, it'd be fun to build a machine that automates the process of making PC boards, specifically etching, because it takes the costs and the resolution down, right? Because you can mill a PCB, but it won't be as, can't do fine pitch footprints or whatnot. But I can use automation and electronics to make it precise. So that's what I've been working on as one of my dozen projects.
How's it going?
It's going a little slow. I started it earlier this year and then had a lot of life career changes along the way. But what I've done is what I always do when I start a new project is go deep and understand, the chemistry of etching, understanding the manufacturing process and processes that are used to when chemicals are used in a manufacturing process. So I have a bunch of pumps and some fluids and some etchants, some boards of different types. And I'm starting to write some, system code to pump reliably. And I haven't got to the chemistry part because I don't know enough about chemistry, but there's a fantastic YouTube channel called NerdRage where he explains chemistry and even has an episode on the chemistry of etching. So now I'm trying to see, what base chemicals should I be using that are both efficient and actually environmentally friendly. So I'm playing around with some chemicals now.
How are you motivating yourself to continue this instead of going on to number 23 or 24?
I get my inspiration for these projects by oftentimes from people talking about it. Somebody on Twitter talking about making PCBs, or in a conversation around someone who runs a makerspace and saying, hey, we buy everything from Washpark, but it takes forever to do a class. So that keeps on re-inspiring me.
It is often re-inspiring, and sometimes it's guilt-making, but it is motivating either way.
I definitely feel guilty after I have this great conversation with someone about an idea, and I see them a couple months later, and I haven't made enough progress to talk to them about it.
And they're like, how's your project going? And you're like, yeah, I started a new one.
Yeah, exactly.
Yes, I've been there. I've so been there. For work, you are a product manager for Particle, and they make things like the Electron, which is a cell modem-based IoT platform. And it's impossible to search for because when you search for Particle Electron, you do not get the help documents.
Would you believe that they changed their former name to be more SEO friendly?
Particle IO?
Yeah, it used to be Spark.
Oh, right. Yes. Yeah.
That was a lateral move. Sorry.
Yeah. Yeah.
I'll give that feedback to marketing.
I have learned to type particle.io and then whatever I want, and that usually gets me what I want. How is that going?
Oh, it's great. It's been a lot of fun working there. One of the reasons I went there was I really enjoyed the founders who I met early on, and so now being part of the sausage making is quite exciting.
Do you have any big plans you can tell us about?
Big plans. I can tell you general big plans and kind of what I'm responsible for at Particle. So I came on board to be product manager number 2, and we view our business in two halves. One is what we call prototyping. The other one is platform or enterprise. So we work on things from hardware to firmware to cloud connectivity and tooling to help you build your true proof of concept. This is that idea of what a true proof of concept is I mentioned earlier. So I look over all those pieces. And then once you have your proof of concept, there's manufacturing at scale, design for manufacturing, test jigs, fleet management, OTA, all these other pieces that come with the scaling part, which somebody else looks after. So I'm super excited about, new hardware that we're working on, which I can't speak to. But the thing that I'm really passionate about is tools. And one of my goals at Particle is to, generally make building embedded systems not just enjoyable, but make embedded engineers and developers proficient and productive. And I think there's a huge opportunity in the space around those tools and bring those to Particle developers.
Are we talking things like static checking and unit tests?
Yeah, the whole development lifecycle from I'm just writing code, so making it more, making the act of writing C++ code more efficient with intelligent suggestions and, refactoring and all those pieces that are readily available for free in maybe mobile world are not as accessible to every developer on the embedded side. But yes, static analysis, profiling, programming and debugging are still clunky in some areas unless you buy really expensive tools. And hopefully find some opportunities to innovate, just like there's been innovation in reducing complexity on the other software world.
Cool. And as part of your job, you recently went to Shenzhen?
Yes, Shenzhen and Taiwan, which were juxtapositions in the electronics world.
This was your first time?
Yep. First time. Spent about a half a week in Taiwan and a week in Shenzhen.
Okay, what was it like?
For someone who loves electronics and getting a new dev kit is exciting, it was amazing. And the team I was with was just giddy as we went through the stores. For the rest of the team who was there, who are more in the back office, they just sat around and said, How much longer are we going to look at resistors, guys?
Did you have Bunnie's book to talk to people in Shenzhen with?
I did not, and funny enough, I found his book for sale at one of the stalls.
That's pretty.
I was half ready to buy it, but I had locals who were bilingual, and they were my virtual bunny.
Virtual bunny, sorry. And so did you come home with a bunch of components for yourself, or was it mostly really a work trip?
It was mostly a work trip, but I definitely compiled a list of things that I thought I needed or I thought I wanted. And in the beginning of the trip, it was really long. And then towards the end of it, I said, why do I need a earpiece that's also a cell phone? So I kept on ripping things off the list that were just nonsensical and a waste of money.
Wait a minute. You didn't bring back the earpiece that was a cell phone?
I couldn't bring myself to bear to buy it. But it's...
Who knows what it does to you? I mean...
There is no form of testing for those products. No form of radiation, anything.
The microwave beam straight through.
Do you have any advice for people who want to become program managers who are maybe engineers or early in their career or college folk?
So program and product management. Again, we'll use those blurred lines because it truly depends on where you go. There are great resources now available online for free. When I started, there was literally no books on product management and one print sort of pamphlet that I found. And now there's great sites. Ken Norton is a great newsletter, or has a great newsletter about product management with great articles and resources. And there's product.careers, which is slowed down a bit, but has a huge list of resources you can go off and dive deeper in. I would say the number one thing I look for when I interview a product manager, especially a junior one, is have they built something? If they're an engineer, do they have a GitHub project that they actually own? Right? There's something there about having an idea of a problem and executing on it. It just so happens that you have the skills to write the code to solve that problem. But if you're thinking about product management, that's a good way to sort of exercise those parts of your brain and think about the product.
And how do you stay current in the industry, or how do you recommend people stay current in the technology pieces?
So, reading everything you can. I think we talked about that earlier. There's podcasts about product management, which are pretty good, but really just understanding the industry at a whole. Talk to other product managers, learn about their processes and some of the challenges that they encounter. But like I would answer to that junior in college who's doing software engineering but wants to do product management, build stuff. Right. Yeah. Become product manager for the thing you want to see in the world. And that's how I constantly hone my skills.
Cool. Are you going to SuperCon in Pasadena?
Yes. Number 3, I think.
Yes.
And I'm pretty excited.
What are you most excited about?
Let's see. The first SuperCon that was in San Francisco, I had the privilege to speak at, which was nerve-wracking and a lot of fun. But I really didn't enjoy the conference as much as I'd like to because I was just done with my talk. But the last one was just a bunch of great inspirational talks, things that I'm super interested in, and things I never even knew I was interested in. And so, getting inspired, meeting the speakers and other makers at the event, and just coming back with another dozen projects to work on.
Yeah. It was, we aren't going. Although we do have somebody who will be handing out stickers. So if you find Ben, ask him, Ben Henke, then you can get more embedded stickers if you go to SuperCon. But we won't be there because I don't need another dozen projects to work on. I haven't finished the last one I went to Pasadena to talk about. All right. Christopher, do you have anything else you'd like to ask Jonathan?
Well, I wanted to go back. We talked about documentation a bit, and you asked the question about open source projects and how to encourage people to do it. But how do you get, and I don't know if you have a great answer for this, but if you come into a place that's already established and they have a lot of code and they have products, and yet there's just a lot of tech debt and things that are undocumented, how would you suggest trying to build a culture of documentation within a company, not a open source hobby world?
Oh yeah, that's a great question. Working on developer products, I value, as a product manager, documentation above just about everything. I'd rather have half the features, but the ones that exist well documented than more stuff. And so far, I've been right about that from the community. The way I do it is, part of my responsibility is to define the things that are important for us to work on. So introducing documentation as a feature of our product and putting that on the roadmap and making a culture of defining something as done, meaning it's deployed, available in the firmware, but more importantly, also documented. So if a feature is not documented, it doesn't exist.
Okay, hang on, I got to write this down.
And so that's one piece. That's one piece of the equation. I've also found that working directly with engineering, a lot of developers value documentation as well and would gladly write docs, even if they're not good at communicating, because they themselves find the value of it. So if you give them that opportunity, they're very encouraged to do it. And the only reason why they don't write comments or documentation is because they just haven't had the bandwidth and runway to spend time on doing it. So saying it's a priority for product, encouraging the engineers and unleashing the value that they see there, and then if that doesn't work, right, and that's not enough, usually you just have to go to customer support. And you now have a third champion saying the time we spend answering the same thing over and over again equals this much money, right? This is how much we spend what you spend on contractors or full-time employees doing customer support. By having a link to the thing that it describes this very common problem with proper troubleshooting as well, will save us this much money. So that has been enough for me in the past to create that culture, but it may not work everywhere.
I take another approach to the documentation problem, which is it's fantastic to be right. It's fun to be right, but without good documentation, nobody knows how right you are. And that, depending on who I'm talking to, that path works okay. Chris, you used the word technical debt, and we have never really talked about that on the show. And I don't think we're going to do a whole show about it now because the sun has come out and we haven't been to the beach in several days. But could you define tech debt?
So a loose definition would be all of those things that you maybe didn't do right in the interests of expediency that you need to go back and fix. Or, well, sometimes it's just bugs, bugs that aren't necessarily customer facing, but are hindering your ability to move forward. So if you have a module that's full of spaghetti code, that's technical debt. Something you don't understand how to fix, that's technical debt.
You have a system that needs to reboot every day at midnight because it reboots at some point.
Yeah, I mean, that'd be an extreme example of something terrible, but it's stuff that's difficult to get buy-in to spend time and resources on because it's not usually customer facing. It's not easy to argue how this makes things better, except from a long-winded sort of, we'll be able to go faster in the future, we'll be more modular, we'll be able to fix bugs faster, we'll be more efficient, that kind of thing.
All right. Jonathan, do you want to add to that or make suggestions on additional ways to prioritize fixing the technical debt we incur just by saying, oh, this warning doesn't matter?
Yeah, the elevator pitch I have around technical debt is in the culture of move fast and break things, it's all the things you broke.
Yes.
They're not bugs that you didn't foresee. It's we purposely didn't do this thing, or we did this thing in another way because we need to ship or because we need to get to market faster. And you said, we'll go fix that later. And there's a to-do in the comments and you never go fix that. And they just accrue over time. And there are all these small incremental decisions that you made with well-meaning intentions, and it's been a year, and you had to hard code the time zone of your server because your batch script is off, and you don't have time to fix it. Like, it's those kind of things. And in big companies, whole products can be technical debt, and I've certainly seen that. And the culture that squashes it early or adds to the sort of bandwidth and your planning to fix out technical debt bugs or handle low-hanging fruits regularly is one that doesn't have these big products that are actually they themselves technical debt. You have to chip away at it early and often.
I agree. All right. Well, Jonathan, do you have any thoughts you'd like to leave us with before we wander off?
Yeah, I think one thing we didn't touch on is sort of the ethos of product management and how I like to work. And I think this applies not just to product managers, but to anyone who's a professional building products for customers. And that's approach the problem with empathy. And empathy for your users, empathy for your colleagues, and that's how you build the best products.
I think that's a great sentiment. Our guest has been Jonathan Beri, maker, author, and senior product manager at Particle. Thank you for being with us, Jonathan.
Thank you very much for having me.
Thank you to Christopher for producing and co-hosting. And of course, thank you for listening. Our quote this week is a little long, hope you don't mind. It's from a book called Algorithms to Live By, The Computer Science of Human Decisions. Seemingly innocuous language like, oh, I'm flexible, or what do you want to do tonight, has a dark computational underbelly that should make you think twice. It has the veneer of kindness about it, but it does two deeply alarming things. First, it passes the cognitive buck. Here's a problem, you handle it. Second, by not stating your preference, it invites the others to simulate or imagine them. And as we've seen, the simulation of minds of others is one of the biggest computational challenges a mind or machine can ever face. So, tell your coworkers where you want to eat.
What if I don't care?
Then
I don't care.
That is never true.
I don't care.
It's never true.
No.
Just say three things. Whichever three things that you don't care about, that's fine. Just choose something.
Don't care, and don't care.
Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.